Okay, so yeah, give me just 1 minute. Just got to load this stuff in the background. Okay, now we can get going. So, let me see. So, first off, the test is due tomorrow. So you still have today and tomorrow to do the regular test. I say today. Today is Wednesday, 10/21. Tomorrow is 10/22. The test is due by midnight tomorrow. Get that done. Make sure to watch all the videos, do the homework, watch the lecture review. We did a good lecture review. We won't be able to do that for every test. That's not going to be an every test thing. That was just we had time to do it. And I honestly felt kind of bad because I had to be out for two out of those, really 4 days of lecture. So I won't, if I have a lecture next time, it won't be as in depth. No one's in the room right now. That's why I'm taking my mask off. But let's start on today's lecture, which is 2.3 and 2.4. I go over this like it's a review because it should be. This is about the equations of straight lines, and a lot of stuff to do with straight lines, like a lot of the kind of background stuff with straight lines and making equations of lines and that stuff. So let's get to it. So the first thing, if you're going to talk about a linear or a straight line, you've got to talk about slope. And we know slope is just rise over run, right? You've probably heard that before. And what that really means on a basic level is if we had a straight line. Now, look, slope, only true for straight lines, okay? If we had a straight line, let's say it goes through -1, 1 here, and then it goes through, let's say 3, 1 here. So it goes through these two coordinates, and I wanted to find its slope, which really is just the slant of the line, right? It tells us the slant, how slanted it is. Well, I always start at the leftmost point, and I go to the rightmost point. So I go from here, and I rise. If I want to get to here, need to think of it as a stair step. So from here, I'm going to go up 1, 2, so up 2, and then I'm there. And then I go over 1, 2, 3, 4. 4 to the right. So my slope would be, well, the rise was, to get to here from here, the rise was 2, so that's the 2, and the run was 4. Now, we write these as a simplified fraction. So 2 over 4, that is just 1/2, right? And because it's going up into the right, it's positive. If it was going down into the right, it would be negative. No big deal, okay? Rise over run, slant of the line. Now, you can also think of this as an equation. And the equation comes from the fact that with slope, which is all about change, okay? I need really your brain to start thinking that slope is about change. The equation of lines, which we're about to get to, is about more stagnation. But the slope tells you the change of the line, okay? How it's moving. Is it moving up? Is it moving down? Is it flat, right? Is it vertical? So it turns out rise is just change in y. Now, delta in mathematics means change. So change in y over change in x, okay? And if you've had a calculus class, like maybe a pre-cal, you've seen this before. But if you plan on going to a pre-cal or a business cal or a calculus class, you're going to have to really grasp this concept that it's the change in, so the equation is y2 over y2 minus y1 over x2 minus x1. So it's okay if you don't want to go on to calculus, I understand, but this is going to be a deeper concept in calculus. So if I was going to use the equation here, Caleb, okay, buddy, here, I want you to sit in the back right there. Perfect. Okay, so the equation comes from the two coordinates. So 3, 1, and then -1, -1. So the way I would work this is actually it's the change in the y over the change in the x. So I've got the two coordinates, 3, 1, and -1, -1. So m equals the change in the y. So I'm going to label this one x1, y1, and this x2, y2. So I get -1 minus 1, -1 minus 1 over -1 minus 3. And you'll notice we wind up with -2 over -4. The negatives cancel, and the 2 fourths simplifies into 1/2. We wind up with the same slope because you can use the equation or you can use the rise over the run. You'll get the exact same output for the solution. Okay, that is slope. This should just be a review, right? You've seen slope before, not a big deal, not too worried about it. Okay, so now we've got to find, the equation of the line. Now there's two main ways to find equation of lines. There's the point using the point slope form or just using the slope intercept. I'm going to go with what your book does just because if you want to use your book as a reference, it makes a little more sense. So your book starts with point slope form. So point slope form. And what point slope form says is actually the equation comes from the slope of the line. If you look back at that equation for slope of the line, we didn't talk about the letter we use. We do use the letter M. Hopefully we know that already. But M is for slope, if you want to write that in there. But the point slope form comes from solving for the y values. So it's y minus y1. Remember, that's our delta y equals m times x minus x1. Okay. And if we're going to use this, hence the name of the equation or the form, we've got to have a point x1, y1 and a slope m. Okay. And then we just plug it into the equation. Now, look, this is not going to be our final answer for most of the equations. Our final answer is going to wind up being in slope intercept, which we're kind of like the diva equation for these straight lines. But this will help us get to that equation. So let's say I gave you a line. A line goes through, let's say -2, 3, and has a slope of 4. So part A, I want you to put it into point slope form. Ooh. Now part B, we're going to put into slope intercept form. So slope intercept form, if you can't remember off the top of your head, is y equals mx plus b. It's really the most common equation. So to put in point slope form, this is our x1 and our y1. We know our slope is m equals 4. So we're going to pop it into this equation. Y minus 3 equals 4 times x minus a -2. So it winds up being x plus 2. There's my point slope form. Very straightforward. Okay. And then now, if I want to get into slope intercept, all you have to do is solve for this y, right? We talked about function notation. With function notation, you had to have the y by itself, because then we could say it was f of x or g of x or whatever. So that's typically for college algebra, the reason we want to get into slope intercept form is because we can write it as a function. So we need to get this y by itself. So to get this y by itself, to go on to point B or part B, let's distribute the 4 through. So we get y minus 3 equals, distributing this 4 through, we get 4x plus 8. And then we add 3. So we wind up with y equals 4x plus 11. So look, two different equations. But if you graph either one of these, they're going to be the exact same line, right? If we want to graph this at a slope intercept form, which we should all be familiar with, this is the y-intercept. So if I go up here to, let's do it by 5s, 5, 10, 11's about right there. And then my slope is 4 now. So that means my slope goes up 4 and over 1, right? So up 4, over 1. So my graph would look like that, right? So each of these is really shown visually by this graph with our X and our Y axis. But it's just two different ways to write it. Now, and again, typically this is the way to write the equation of a line. And if your test or your book asks you for the equation of a line, this is what it's asking for, because we can write this as a function because y is by itself. If we wanted to, we could write this as f of x equals 4x plus 11, right? In function notation, which you guys take the test already? Okay, yeah, it's open until tomorrow midnight, right?
I wasn't able to. That's why I was so worried about it. And I wanted to make sure I got the review.
Oh yeah, I got you.
Because I've seriously been having doctor problems and wrong medication stuff. So I've been just going home.
Oh yeah, you can tell me about it. Tell me about it. We'll talk about it. It's no big deal. Okay, wait. Any question though before we go on from this kind of basic stuff with slope? So let's do another one. I got you. So let's say instead of me giving you the point and the slope, I give you two coordinates, which is a common thing to do as well. So let's say all we know about this line is it goes through. I'm going to steal it from the book. 4, -3, and -2, 6. And I'm going to ask you the same exact things, actually. Actually, I'm going to add one in here. First, I'm going to ask you to find the slope. Right? Given the two coordinates, let's find the slope. That won't take long. And then let's put into point slope form. Point slope form. And then down here, let's put into or find. You'll see the book uses the word find or put into y equals mx plus b. So slope intercept form. Okay, so let's do that. So first off, to find the slope, we know it's just the change in y over change in x. So let's see here. So I'm going to call this, x1, x or y1. Then this x2, y2. Marker's kind of not fine enough to write up there. But if we did change in y, we'd do 6 minus a -3. So really 6 plus 3, right? 6 minus -3. And then -2 minus 4. So we'd wind up with, what's this, 9 over -6. Ugh. Fractions. So 9 over -6, now it's going to be a negative. So I'm just going to, actually, I like putting the negative in the numerator when it comes to slope. That has to do if we graph it later on. It's not a big deal though. 9 and 6 are both divisible by 3 though. So it's 3/2. So -3/2.
You're like the one math teacher that doesn't like that.
Oh no, fractions are the worst. Negative. If I told you that something costs 3/2 dollars, does that make sense? No, exactly. Okay, so 3/2. Now put this. Now we want to put into point slope form. So if we've got m equals -3/2. Now look, for point slope form, remember we need a point. It does not matter which one you choose. So really, there's two correct answers for B. There's point slope form with the first coordinate or point slope form with the second coordinate. I'm going to use the first coordinate, okay? And remember, the equation was y minus y1 equals m times x minus x1. So we get y minus really plus 3, right? Y minus a -3 equals -3/2 times x minus 4. And I know what you're thinking. You're thinking, well, I could use the other coordinate. And you're right. I mean, if we want to use the other coordinate, you're right. It's y minus 6 equals -3/2 times x plus 2, right? Either one of these is correct. And when you start working on the homework, you'll see these questions have two correct answers because of that. Now, I'll tell you, it does not matter which one you use. You can get it into y equals mx plus b from either one. I'm going to just start with the first one because that's what we started with. So I'm going to distribute the -3/2. Remember, the goal now is to get y by itself. So distribute the -3/2. And you get, well, -3/2 x. Now, -4 times a negative, so that's going to be a positive. 4 times 3 has, remember with an integer and a fraction, you multiply the numerators. So I'm going to do this in one step, guys. Just multiply the integer by the numerator. 4 times 3 is 12. Then you divide it by 2, you get 6. Okay? You can use a calculator, right? I'm not stopping you from doing that. So subtract 3, and you get y equals -3 halves x plus 3. Boom. Okay? Now, if for fun, actually, let's do part D. Not for fun. Let's make it part D. Let's graph it. So we've got negative slope. We're going to be going down. We're going to start at 3, though. And really, this equation is written backwards. And it's one of my pet peeves as a math teacher, because if I ask you to graph this, what's the first thing you're going to graph?
You're going to graph the slope, aren't you?
No, well, slope's about change. So what are you going to? You got to know where to start. So what would we need to graph first? Yeah, that's fine. You got to graph the y-intercept, right? You got to graph the y-intercept first. That tells you where to start. The slope here tells you how the line is moving, right? The slope is about change.
It tells you the direction.
Exactly, tells you the direction. You're exactly right. So really, think about it. This equation is written out of order. The y-intercept should come first, because that's what you have to graph first. Okay, and then you graph the change. So I'm going to go down 3, 1, 2, 3. And then over 2, we wind up on the other axis. And boom. We've got the line. Yeah. It's kind of like saying, hey, I make, I don't know, like, oh, I make $100 a week. Well, that's great. That doesn't tell me how much is in your bank account, right? Like, oh, yeah, I make $100 a week. Oh, but I started with negative 5,000, right? Yeah. So it's I guess it's kind of the way to think about it. Yeah, it is. And when you've taught it for over a decade, it's really fun. And really, if you take a stat class, in statistics, the equation is written that way, which is really weird. Like,
that word makes me shiver. As a class, statistics.
No. It's a good class.
Same thing with calculus.
Yeah, you should take statistics. It's a good class. Okay. So we got y equals mx plus b. Kind of going through here. Okay, yeah, let's talk about kind of weird lines. Let's do the same thing we just did, but I'm going to give you 2 lines that make kind of a weird slope, and we need to graph them and see what happens just to get comfortable with them. So let's say we go through -2, 4.
There's a weird effect going on with your camera.
Oh, I'm shaking. It's my knee, probably. Is it not doing it now?
Go ahead and move your left hand to your right hand. Go ahead and move your left real quick.
Oh, yeah.
Isn't that weird?
Oh, that is weird. Ooh, it's trippy. Okay. -2, 4, and let's say 3, 4. That's okay, man. So first I want to find the slope, and then I'm going to do the same rigmarole. Okay. Let's find the point slope form. Ooh. And then let's find, what was it? Slope intercept, y equals mx plus b. And then lastly, I am going to graph it. I'll graph it down here. Did it do it again? Want to put my hand up there? I think it's weird. I don't know, man.
Maybe it's your nails. Maybe it's refracting the light.
It's got to be something. Okay, anyway. So the slope, though, we're going to get a different kind of coordinate here. And I'm going to tell you the reason I noticed that, or the why I can tell from the coordinates, is that the y value does not change. Okay, so it's going to cause a 0. Let's see where the 0 is at. So for slope, we're going to do 4 minus 4 up top, right? Because that's the change in the y's. And then the change of the x's is 3 really minus a -2, so 3 plus 2. So you wind up with 0 over 5. Look, if I have, what this fraction's telling us is if I have no money and I divide it into my 5 children, which I do not have, but if I had 5 children, if I've got no money and I divide it into my 5 children, they all get no money, right? Okay. Because I have 5 kids, exactly. So my slope's 0. So let's see what happens with the equation of this line. For point slope form, you'd have y, again, it doesn't matter what coordinate you use. I'll choose this first one. Y minus 4 equals 0 times x plus 2. So this would actually be the point slope form. But what happens is that 0, of course, we know anything multiplied by 0 is 0. So you can distribute it, I guess, if you want, or you can just say 0 times anything 0. You wind up with y minus 4 equals 0. This whole side goes to 0. Add the 4 to the other side, and you just wind up with a y value, right? Now, if you just wind up with a y value, what this means on the graph is that there's no rise or run, right? That tells us that there's no rise and there's no run. You're flat line. Let's use a different color. 1, 2, 3. So let's see if this other color picks up. So again, this is my y-intercept. So I go up 1, 2, 3, 4, but I don't have an x value. I don't have an m, right? My m is 0. So I don't go up and I don't go down. I just go flat. I go straight. Okay. So this graph actually is a horizontal line. And all of this tells me we have a horizontal line. Okay. Horizontal lines have a slope of 0. They have an equation where it's just y equals a number. And of course, on the graph, they're just a flat line. Okay. So this is just a good example of a horizontal line. You've got a slope of 0. Y equals a number is whatever the slope, the equation of the line. And again, if you wanted to write it as a function, it would be f of x equals 4, right? And look, it doesn't matter what x value I plug in, you're going to get back a y value of 4. That's what this coordinate kind of told me, actually, these two coordinates. Look, it doesn't matter what the x value is, the y value is always going to wind up being a 4, okay? Any questions about that in Zoom land? If you guys have a question, ask me. Well, it's just you and me, Brianna. Something must be goofy because usually we have more people coming in. But that's okay. We'll be watching it later. You might have to butt in on me, Brianna, if you have a question, because sometimes the chat doesn't pop up, and I don't know why. I wish they'd fix that Zoom feature. But you are not disturbing me if you want to pop in and ask a question. Okay. So that was a horizontal line. Okay, let's talk about now vertical lines. They're a little weirder. So vertical lines, the x values are going to be the same. So we're going to go through. And now we're going to make the x values the same on this one. Let's say 2, 4, and 3. Actually, 2, 4, and we got to keep the x values the same. Let's say 2, 7. Okay, 2, 4, and 2, 7. So I'm not going to do as much here because you'll see why here in a second. If you remember what the slope of these are. The slope for this one is going to be, now the change in the y would be 7 minus 4, right? Change in the x would be 2 minus 2. So this would be 3 over 0. Now this one really doesn't make sense. Now think about this. If we go back to our child example, this is like saying, hey, I've got $3 and I have to give it into my no children. So I've got $3 and I've got to disperse it into my inheritance, into my children, but I have no children. It doesn't really make sense. Have you asked Siri how to divide by 0? She has a very interesting, or explain divide by 0. She goes through like this whole Cookie Monster example and sharing cookies with your friends, and it's actually kind of funny. That was true like 5 years ago. I don't know if it's changed. I'm not an Apple guy, but I know someone in my class did it, and it was pretty interesting, actually. But for now, we've stated in the past, in a previous math class that you've had somewhere in the past, that anything divided by 0 is just undefined. So it doesn't get a cool number. It doesn't get a Greek alphabet thing, okay? It's just undefined. Now, because of that, I can't go on and do the point slope form. I can't go on and do slope intercept form. These do not work. A vertical line, this is a vertical line, okay? This is a vertical line. This tells me it's a vertical line. Vertical lines do not line up in that form because what happens is you don't have a y value. It's only an x value. So if I wanted the equation for this line, It's just x equals, and it's whatever the x value stays. So x equals 2. Okay, that's the equation of this line. And it has an undefined slope. So we can't do the other stuff. We can't put it in point slope form. We can't put it in slope intercept because there's no y value. And all of those are really based on the y. Now, if we want to graph this one, though, we're stuck at x equals 2. Okay, that's the best way to think about it. This is the x-axis, right? That's the x-axis. And our equation's x equals 2. So our line is stuck right there. That purple's coming through pretty good on my side. I'm not sure if you can see on yours. We're stuck at x equals 2. So that means we have a vertical line, okay? And those are all the types of vertical line, or all types of lines. We could have just a regular line that winds up y equals mx plus b, like a normal line. We could have a horizontal line, which we went over before, or we could have this last kind of vertical line. Now, I'll tell you, vertical lines do not line up well with college algebra. Well, I mean, they don't line up well with the function part of college algebra because this line is not a function, right? I mean, if you graph this, it does not pass the vertical line test, right? So therefore, it's not a function. So it's you won't see it as often because of that. You won't see it as often because it doesn't kind of fall into that nice pattern from before. Now, your book goes over, if you're following along kind of in the book, your book goes over on page 250 and 251, the general form of a line. I am not going over that. I don't even know why. I don't know why algebra authors even use that equation. Okay. So now let's go on to 2.4. I'll give homework on this here in a minute. Actually, yeah. Let's go on 2.4. There's a fun example of 2.3 if we've got time, which we should. It's 8:30. So 2.4 is one of my favorite titled sections. Moron slope. And the first thing that your book talks about in the moron slope section, this is 2.4 now, we're kind of turning to, are parallel and perpendicular lines. Now, I'm not going to write this out. I'm going to shorthand it because I'm efficient, not lazy. Parallel, you can write with two lines like that. That means parallel. So if you want to notate it so you don't have to write it, that means parallel. Perpendicular, you use an upside down T, and that means perpendicular because those two lines hit at a perpendicular line and these two hit at parallel. Okay, so the only thing we really need to know is that parallel lines have the same slope. So parallel lines have the same slope. Perpendicular lines, though, have opposite reciprocal slopes. Opposite reciprocal. I think it's a no. So I'm going to go over what that means, what opposite reciprocal means. I think I spelled that wrong. I think it's an A. But we'll go over that first. So opposite reciprocal means you're going to flip it and change the sign. So let's say let's make a little chart here. I'm going to give you the slope. I'm going to ask you for the parallel slope and then the perpendicular slope. Okay? We'll do a few of these. Okay. So let's say the slope of a line, let's say we know a slope is like 2/3. Well, we know the parallel slope's going to be the exact same. Nothing changes. Okay? The perpendicular, though, as a fraction, you're going to flip it and change the sign. So this becomes -3/2. Okay? Flip it, change the sign. Pretty straightforward. Not a big deal. So if let's say we had a slope of a line that was like 1/2. Well, parallel line, it's the same exact slope. Not a big deal. Just 1/2. The perpendicular, though, you're going to flip this so it becomes 2/1. And you're going to make it negative. Now, we know 2/1 is just 2. So this winds up being -2. That would be the perpendicular line. Okay? Let's say we had like -7. Okay? -7, I'll tell you, you need to kind of think of it as a fraction once we get to the perpendicular part. But for parallel, we know it's the exact same, right? The exact same. But now for perpendicular, think of it as -7/1. right? You're going to flip it. So it's going to become 1/7 and change the sign. It was negative. Now it's positive. So that's my parallel line. Okay. So now let's think of 0. So the parallel line to 0 would be 0. What about perpendicular? No, -0 is just 0. It's a good guess there. Can't be 0 because that means it's parallel, right?
Is it like undefined or something like that?
Beautiful. Beautiful. Undefined, right? Remember, this is a horizontal line. Can you guys see at the bottom? This is a horizontal line because it has a slope of 0. And horizontal line, flat, right? Boom. Vertical line, undefined. Slope. Okay. They're going to try to trick you in the homework and probably me on the test by doing this. So I'm telling you that now. I'm not trying to trick you. It's that the vertical and horizontals don't line up in that same kind of formulaic way that the other slopes line up in. So it feels like curveballs on a test because they just don't line up as normal rational numbers. Okay. So be careful. That's going to pop up on a test. And it's not hard per se. If you know it, it takes 2 seconds. It's just one of those where you've got to know it. It's one of those kind of things to know in the background as you're taking the test. Okay. So there's our perpendicular and parallel slopes. And I'll let you do the homework on those. It's not a big deal. It's kind of like you're doing the same stuff from 2.3, but you're dealing with parallel and perpendicular lines. I want you to hit those on your own and then come to me with questions. So I'm going to give those for homework. Now, I know it's kind of hard. This 7-week classes are tough with the amount of homework that's kind of given to you each night. But for this night, I need you to hit a few of these. You don't have to hit all of them, but hit a few so you've seen the majority, and then come back and work a few more once you have the time, if you can't get them all in. Okay, that's parallel and perpendicular. Your book goes into a lot more of that than me. But I want to talk a little bit about now rate of change. This is a 2.4 topic. Yeah, we did. So let's talk about rate of change. Now, I'll tell you, rate of change is used when we don't have straight lines. So, what's the word? What's that word called for that type of line? Oh, it's going to bother me. Oh my gosh, I forgot a word. Secant line, yeah. Slope of a secant line. So if you're not sure what a secant line is, that's fine. I'll show you an example here in a second. But it's slope of a secant line. That's all the rate of change is. So let's look at an example. I'll tell you, rate of change, we're not dealing with straight lines anymore. Okay? We're not dealing with straight lines. Let's say, make this one a little bigger because we're going to steal some coordinates off of it. Okay, we're going to use some real world data here. Google it, some stuff. Let's look at a stock. I'm going to tell you a stock that I own because my wife goes there way too often. I decided to buy TJ Maxx because I've spent too much money there. And let's look at TJ Maxx, let's say over the last 6 months, just to see what happened. Actually, so 6 months ago would be what? April. Yeah, let's start with like April 1st. April 1st, TJ Maxx was at $44. So I'm going to label it here. I don't think it gets, yeah. Now, this isn't a good graph. I'm going to just start at 40 and then go to 45 and then go to 50. Okay, you're supposed to start at 0. Don't call the math police, please. So on April 1st, this thing, what did I say it was? $44. So April 1st, we'll call that 1. So really, this 1 correlates to April 1st, okay? For X. X equals 1 is April 1st, and we were at $44. And then a month later, May 1st, we're at $48. Hey, we're making money. $48, right? And then April, May, June 1st, we're at $51. Oh my God. We are rich. Okay. Holy cow. Yeah. And then April, May, June, July. July 1st. We're still at $51. So it looked like this. This was a good 4 months for TJ Maxx stock, right? Now, of course, if you looked at this, it's going like this the whole time, like every day, right? But notice it's not a straight line. This is not a straight line. I mean, if you look at any stock graph, it's not going to be a straight line. It's going up, it's going down, it's going left, it's going right. But the question I'm going to ask you is find the average rate of change from April, was it to July? April, it's weird thinking of April as one. April, May, June, July. April to July. So find the average rate of change from April to July. So what we're actually doing, and this is what a secant line is. We're going to think of a line going from, now here's April, here's July, right? We're going to think of a line going through those two coordinates. Okay? And what we're going to do is we're going to find the slope of this. This is called the secant line. Okay? Slope of this secant line. So we've got the two coordinates here and here. And we know those two coordinates, right? They're given to us. Or I kind of gave them to you right there. We've got 1, we're at 44, and 4, we're at 51. So we just find the slope in that same manner. The change in y, 51 minus 44, over the change in x, so 4 minus 1. So 51 minus 44 is what? 13 over 3. And this is what I was telling you about, Caleb. It doesn't make sense to say 13 over $3. It would be dollars per month, right? Because it's a rate of change. The numerator right here is in money. And then the denominator right here is in months, right? So it's dollars per month. So I'm going to take my calculator out and I'm going to say, well, what is 13 divided by 3? And I'll round it to the penny because we're dealing with money. So it's $4.33 per month. So look, this secant line represents me making $4.33 per month, right? So if I stayed on this trend, I would make another $4.33 a month for this stock. That seems crazy, but I guess that's what it was. I mean, we went from $40 to, oh no, it's $44. I didn't draw 44 is like right here. You guys didn't call me out on that. I was way off on that dot. This should be right here because that was $44, and I don't know why I drew it at 40. Let's imagine this is 44. There, I fixed it. Okay, so $4.30 a month. So if it stayed on this pace, and of course, if you look at every single other dot, it is not doing that. Okay, if I wanted the rate of change for any 2 other months, I'm not going to see that kind of increase. Okay, I'm not going to see that kind of increase. Like if I asked you the same coordinates, but I want you to find the average rate of change, we'll say ARC, from, let's say, April, May to July. So from May to July. So now we're going to go from May, which is right here, to July. So if I wanted to find the average rate of change, it's just the slope. So it's going to be 51 minus 48 over 4 minus 2. So 51 minus 48 is 3 over 2. So 1.5, we're still increasing, right? We're still increasing, but look, the trend here. So now this is from May, which is right there, to July. So if we think of that secant line, it's right there. And notice it's got a smaller slant to it. So it's not increasing as fast. So what's happening, and actually, if you want to look at the stock graphs for TJ Maxx, what happens is it's going up and then it's starting to kind of level off right now. Okay. And that's what that secant line slope tells us. At 433, if you look at the overall, hey, we got this nice thing. If this went forever, we're going to make another $4 a month for forever, which that's not what happens, right? But what's happening is the closer we're getting to April, the secant line is getting closer and closer to zero. And actually, from the last 2 months, it is zero, right? Look, there's no change in the amount the last 2 months. So therefore, if I found a slope there, we know that's zero, right? Remember the y's are the same? That's just a slope of zero. We went over that a little bit ago with that other example. So kind of neat. This is a real world example of slope as rate of change. And if you ever wind up having a significant other that spends too much money at TJ Maxx, this will make you feel a little better because every time they spend money, you make money in a small way. That's how it works. That's how I like to think of it in my head. It's not what actually happens. Okay. So let's look at this now equationally. So equationally, if I gave you a function that was not a straight line and I asked you to find the average rate of change, let's look at f of x equals the square root of x. And what I'm going to do is I'm going to graph this thing out. You don't have to do this. I just want you to show I want you to see what this looks like because we're going to be dealing with this function in a few sections and we're going to get more comfortable or familiar with it if you've never seen it before. Okay, so if I put in zero, I'm going to get x's and y's back. Okay, I can't put a negative in here, right? Square root of a negative is imaginary. I can't graph it. So I'm going to put in zero and I get back zero. That's my first coordinate, 0, 0. Put in 1. Square root of 1 is just 1. Right there. Now look, you can put in like 2 and 3, but they don't have nice square roots, and I'm going to be lazy, and I'm only going to put numbers in that have nice square roots. So I'm going to put in 4, and I get back 2, 3, 2, 3, 4. I get back 2 right there. And then if I put in, the next one would be what, 9? I get back 3. It's over there somewhere. So look, this is the graph of this line. And notice it's not a straight line, right? This is not a straight line. And we're going to look at these 3 coordinates. We might even pull in that 9 and 3. So here's how I would ask this. Find, and this is how the book asks it too, the average rate of change from, and now look, for this example, you have to be given 2 x values, okay? I'm going to say x1 equals 0 and x2 equals 4, okay? Find the average rate of change from x1 equals 0 and x2 equals 4. So look, we've got to find, so really what we're finding, let's kind of graph this now. If I want to go from 0 to 4, what I'm finding is the slope of this secant line, okay? I want to find the slope of that secant line. And I know 2 coordinates on it already, right? I know 0, and to get back the y value, you just plug it in. So I know 0, 0. And I know 4, and when I plug it in, I get back 2. So my average rate of change would be the change in the y, so 2 minus 0 over 4 minus 0. So it winds up being 2/4, which is 1/2. Okay? Thrilling. Yeah, I know. You don't have to tell me. I know this is super interesting. Okay. Question, Brianna. You're the only one on the other side today. The only time this has ever happened is when like Blackboard had goofy issues.
Only like one person here and one person here.
Well, usually, I don't know. And I know a few people have already emailed me saying they were going to watch the video later. But, oh man, it's a big enough class where we should have had, usually people come in. There was one time, were you here first 7 week, or were you in like taking classes? You kind of come in, or in like, we're taking like history or something different.
I was the first week when like the first week that this was like that I had this class.
Yeah. Okay. At one point, Blackboard went down, and it was like, why is no one in my class? But yeah, it's because the internet, or not the internet, but
I actually didn't check my email on Monday morning. I didn't check my email on Monday morning, so I didn't know that you canceled class, so I stayed for like 20 minutes.
Oh
And I
no.
was like, okay, well, I guess.
Yeah, they wanted us to do all Zoom classes for the first day. Okay, hold on. Let's get back to that actually here in a minute. Okay, so let's look at one example. You didn't bring college algebra book, did you? This is an example on page. Actually, no, I'm going to give for homework, and then I'm going to go over it if you have any questions. So for homework, remember these were 2 sections, so 2.3, which is on page 255. I want you to start on 1, and this is going to seem like a lot. You do not have to do all this. You can do every other odd if you want. That is fine with me. But I want you to see all the different types of ways these questions could be asked. Okay. 1 through 57 odd. All these are going to be odd. I want you to do 67. Now, we haven't talked about the like 67, 69, and 71, but I like those questions. And if you get stuck on them, ask me in class. Not a big deal. So all those are going to be odd, and then I'm going to pull some from the real world stuff. So 87, 89, 91, and 92. Try those. It's kind of some neat real world stuff. 2.4, which is on page 267. Five through 5, 7. They just don't ask a lot in this one. Oh no, yeah, they do. 5, 7, and then 13 through 23 odd. This one does not actually no, and I'm sorry. Yes. And I'm gonna pull out some real world ones. 25, 26, 27, 28, and 29. Okay. So check those. And again, for kind of this is a lot going on right here. You could do like every other odd on those and you'll be fine. Just make sure to hit the other ones because it asks this a little differently. Can you pick it up in there? You got it, Caleb? Great. Okay. Any questions, Brianna, before we wrap today up?